Hi, this is David Harper of Bionic Turtle with an illustration of how we construct a confidence interval, one of the two approaches we use in statistical inference. To do that, I've pulled a list straight from Guarte's Essentials of Econometrics. This is a simple list of PE ratios, that's price to earnings ratios, for 28 New York Stock Exchange companies. The date doesn't matter for our purposes. So I've got a company and a PE ratio. So what I have here is a single column of PE ratios. There's 28 companies. I collapsed in the middle just to make the data set smaller and more manageable. You can see I'll expand there. So we really do have 28 companies in there. And then I'm going to take some statistics of that data set. I've got a mean, which is the average, so that's Excel's average function. I've got a variance, which is Excel's VAR function, and a standard deviation, which would be the square root of the variance, and my standard deviation is about 9.49, and I can use the Excel function STDEV. So I have three statistics. What I have are the mean, which is a first moment measure of central tendency, and then I have two measures here that are second moment measures of dispersion. Now I'll take the count, see how many data points I have. I'm using the Excel count function there. It returns 28. My degrees of freedom are the number of in my sample, or in this case the count, minus 1. My degrees of freedom in this case, because I have 28 companies, is 27. Now I need to select a confidence. So this is a decision I make. I just input this. I've selected 95%. Now what I need is, in order to construct the confidence interval, is I need a critical T value. So this is just like before we had Excel. We would have to look these up in the back of the statistics textbook. But with Excel, I can just use the TINV function, open parens. It only requires of me a probability and a degree of freedom. The probability is my level of significance. Significance is 1 minus confidence. So if I want a confidence interval 95%, I want 5% significance, so it's 1 minus 95%, comma, then I give it the degrees of freedom. Those two parameters returns for me a critical T of a little bit over 2, which is about the sweet spot for the critical T. What does this mean? Well, if we look at the chart here on the right, I've got two lines. One in green is the standard normal distribution, the bell curve. In red with dots is the T distribution. Notice how close they are. My sample size, as it gets close to 30 and above, the T distribution is going to approximate the normal, and that's what we're seeing. If you look at the red, I'll bring the degrees of freedom down real quick. Just look at the red line. I'll bring the degrees of freedom down to 4, and notice the T distribution does really reveal itself with the fatter tails, and that's why we use the T distribution instead of the normal distribution when the variance, the population variance, is unknown to us, because it accounts for our uncertainty given the small sample. So I'll put this back. We're still going to use the T distribution with 95% confidence. We've got a critical T of about 2. I'm going to move this down a little bit. What does it mean to construct a confidence interval now? What it means is, if we look at this distribution, if I start here at the mean the mean's going to be 0 if I standardize the random variable. If the mean is 0 and I go left by 2.052, that's my critical T. If I go to the left by 2.052 standard deviations, plus if I go to the right 2.052 standard deviations and draw a line, if I bound this, sort of slice this distribution, then the area under the curve within those two bounds is going to equal about exactly 95% of the area of the total area under the curve. That means if I have a random variable that is characterized by this T distribution, I can say with 95% confidence it's going to fall within that bound that it has on the lower side negative 2.052, and on the upper side positive 2.052. So I can use that to construct my confidence interval one thing I need to do is my standard deviation is really going to be my standard error in this case, which is I take my standard deviation, that's up here, and divide it by the square root of n, or in this case I have 28 data points. And what I've done there is, if you look at this formula for the critical t in yellow, that's the denominator. The sample standard deviation divided by the square root of n. That gives me the standard error, which is pretty much my standard deviation for the sample mean. Now I can construct the confidence interval. Here in yellow is my critical t, and all that says is my sample mean minus this population mean, the difference between those, divided by this standard error. So what we're doing with the confidence interval is we're trying to create an interval with a lower limit and an upper limit that we can say with 95% confidence within that interval lies the true population mean, given here by u. So if I just rearrange this formula, come out here, what we're going to say is with 95% confidence, this true population mean right here in the middle of orange is bounded on the left by this and bounded on the right by this. Where these formulas are the same, this is just minus and this is plus. So on the lower limit, we're taking the sample mean, we're subtracting the critical t multiplied by the standard error. And so if I go over here to lower limit, I'm going to take the sample mean and I'm going to subtract the critical t multiplied by the standard error, 19.57. And if I go to the upper limit, I'm going to take the sample mean, and this time I'm just going to add the critical t multiplied by the standard error, and I get 26.93. And so you can see I have a lower limit and an upper limit. In the middle is my mean. So if this is in standard units, this x-axis, but just imagine the mean here is at 23.25. I go over here to the left, my lower limit is at 19.5 about, my upper limit is about 27. What I've said is, based on the idea that my random variable follows a t distribution, I have 95% confidence that this true population mean, that's this here and here, which I have nowhere observed really, is going to lie somewhere within this confidence interval bound by the lower limit and the upper limit. So I hope that's helpful. This is David Harper, the Bionic Turtle. Thanks for your time.